F6 incline with 2 pulleys. So in this situation, say we have a wall here, and we're going to have an incline over here, like this. And there's going to be a pulley here that's going to go up to connect to the top of the wall here. Going to wrap around to another pulley. In other words, we have 2 pulleys with a doubling, and then have some mass here, M1, M2, right angle theta. So in this rope, there's tension everywhere. T, T, T. It's nice and taut. And in this consideration, we're going to ask some questions. We want to know the acceleration A in terms of G, where M1G, the weight of the first one, is 25 newtons. The second one, 75 newtons. The angle is 70.1 degrees. And US, well, this would actually be a kinetic because we are moving. Kinetic. Let's just go ahead and make that by definition mu, so we don't have to write down the subscript. Question 2. What is the acceleration if we got 90 degrees? In other words, you make this, just imagine this coming in so it's real thin region there. And the question here, next one, is to ask about the balance, the 2 masses. We want to know the condition for them to be balanced. And then 3, what is the acceleration in terms of G if we have 82 newtons for the first mass and 22 newtons for the second one with an angle of 60 degrees. And we'll assume this is a 60.0, so we have 3 significant figures, and the mu is 0.21. So we have some numbers. We have some numbers to consider. So this is our sketch and our 4-step approach, and then we need to have the force diagrams. Force diagram, and we'll have one for mass 1. Go ahead and have that one slanted like this, where there is a normal force pushing up. And then here, this is tricky. Since you have 2 ropes pushing up, T and T, we're going to have 2T. And that's the strength of the pulley. See, you're basically doubling up your strength by that extra pulley, the pulley principle. And then we have, there is M1G, and that's your angle theta. And if you want, you can have theta here, and they're both complementary to that angle. And then you have here, we're going to assume that up is positive, and we are going to assume that we are going up. And if for some reason we find out we're not going up because of the masses, we have to redo the problem. So assume going up. Then the friction will be opposite whatever you're trying to do. So we have 2T mg, and it looks good. And then for the second mass here, down is positive to be consistent. When this M1 goes up, the M2 goes down. And we'll have T pulling up and M2G pulling down. Now we're ready for step 3, and that would be Newton's equations, Newton's laws. And for the first one here, we'll have 2T going up minus M1G sine of theta minus the F going down is M1A. And then the second equation here, N going up minus the M1G cosine of theta, and that's 0 because there's no motion that way. And then the friction equation, mu n, the auxiliary equation. Then for over here, for this case, we would have M2G going down minus T is M2A. And now we have a problem because you see this A is going to be different than the other A. This A is going to be A times 2. Now here's why. When you pull down, say 1 meter here, since this is doubled up, it'll have half a meter and half a meter. So this will go up a certain distance. This one's going to go down twice the distance. And that makes sense from the point of view you get nothing for free, that if you get this T and turn into 2T, you're going to have to work extra, go twice the distance to get this to move up half the distance. So that's an important consideration, that the acceleration due to mass 1 is A, but the acceleration due to mass 2 is 2A, because this will go twice when this goes up 1/2. So we'll need that equation in there. Okay, so then the next step is to solve. Right? And for solving the equations, I like to work from the bottom up. So these two equations would get me F is mu times N, which is M1G cosine of theta. And then I would put that in here and have 2T minus M1G sine of theta minus mu M1G cosine of theta equals M1A. And now the second equation, notice, has 1T instead of 2T, so I'm going to multiply this equation by 2 and get 2 M2G minus 2T equals, now I'm going to have 4 M2A over there. Now I can add the equations to have the T's cancel. And by adding the equations, 2 T's will cancel. And we'll have here minus M1G sine of theta, this first one. Then this, you're also going to have this in there. Let me write the top ones down first. Minus mu M1G cosine of theta. And then we'll also have a 2 M2G. And then on the right-hand side, we're going to have M1 plus 4 M2 times A. So we're almost finished here to solve the acceleration. So at this point, I'm going to write down the positive one first. I'm going to say acceleration is 2 m2, and I pull the g out at this time, and then here I have minus m1g. Let me put the g in. I changed my mind. Then I'm going to have here sine of theta plus mu cosine of theta. Since the minus sine is here and 1g is here, then I have sine of theta and the mu cosine theta in there. And then I'm going to divide everything by this mass combination, m1 plus 4 m2. And that's the equation. And if you like, you could put the g on the outside. So now it's time for some numbers. So the numbers here, we have the m2g. So in here, we're going to have 2 of those. So there'll be 2 times 75 goes in there. And then the m1g, what'll go in here is, let's see if we can, we'll say 25 is going to go in here. And then notice that that's the g is included there. That's the mg, that's the weight, 25 newtons. And this is 2 times 75 newtons, plus m2g is this 75. And then here we'll put the 70 degrees in there and in there. And we need in here 0.2. Now here, see, what I would like to do here is I would like to put in, I would like to, in other words, multiply top and bottom of this equation by g so that I get my answer in terms of g, but also I then have the weights because m1g is going to be 25, and then I'm going to have 4 times 75. Now in the textbook, you know, I have this worked out for you, and you do have intermediate steps with numbers shown. And when you do all this, you get 0.38 g. So for the second question, what about when the angle is 90? Well, that simplifies a lot, because if the angle is 90, then we're going to have the acceleration. We're going to have 2. Let me just write this equation over again here. 2 m2. In fact, I'm going to subtract, I'm going to pull out the g here. Just a personal preference, not a big deal. If you don't want to do it, it's okay. And 1 plus 4m2. I think that's the cool equation. All right, so we have the m2, the minus m1, we have a combination here, we have that. And notice that the acceleration is in terms of g, since all these are, when they divide out the masses, you're going to get no dimensions coming in there. All right, so now it's going to be easy because we're going to have a 90 case. So m2 minus m1 sine of 90 plus mu cosine of 90 and 1 plus 4m2. And the cosine of 90 is 0, and the sine of 90 is 1. So we have a very nice simplification. We have 2m2 minus m1 over m1 plus 4m2 g. And now you can see that to balance, Because when you have the 90 situation, what you do there, it's basically like having this tied to the ceiling. Like that. So you have, you know, T going up here, and you have, say, you know, here is, well, the T on the other mass would be going up. But the idea here is that if you want to balance, let's say, a mass here with the mass there, since you got T's everywhere, and you know, here there'll be a T, you know, pulling on this mass, will be pulling up. So here, since you had the two T's going up, you can balance something twice your weight because you have a T going up and you have two T there. So here, if you look at this, the math, it just simply says you want to get balance, we want the acceleration to be 0, like that's going to be balanced. So that means 2m2 equals m1. So the second mass, let's label these. This is m1 and m2. The mass on the right, say, is 1/2 the mass on the left. So it can like double up its strength by this looping of the tension in the cable. Tension in the cable. So the last question is, what's the acceleration if you have these values? Well, if you have these values and plug in all these values, and I do this for you in the textbook, you get bad news. So for part 3, you get acceleration is minus, and when you have that, everything is wrong, because you're not going to have the friction in the right direction. So in other words, things are going to go the other way, because see, now mass 1 has a weight that's too high. It's like almost 4 times. So what you have to do is you have to redo the problem from scratch, or what you can do is say, well, if I did the problem over again, I would have the force of friction going the other way. And the way to do that is simply to just flip that mu to be negative. So if we flip that mu to be negative, then we would have, for the new equation, 2m2g, but I'll put the g back in now, m1g, sine of theta, and now the negative sign in front of the mu. It's good to do this once in your life, like from scratch again, so you feel comfortable with this switching of the sign. And you can see that if the sign got switched for the frictional forces, basically the mu is going to be negative. It'll take care of that. So it will go all the way through till the end of the calculation. So this is m1g plus 4m2g. And this would be multiplying g out there. Okay, so I'm all set. I'm all set here to plug in some numbers. So the m2g is going to be here 22 newtons, and the m1g is going to be 82. This is going to be 60 degrees, and this is going to be 0.21, and this will be 60 degrees. And then here, m1g is 82 newtons, and this is going to be 4 times 22. It's going to be 88. So when you work all this out, you get the acceleration is minus 0.11 g, and now that's good. Now, if you're worried about the minus sign, it wouldn't hurt to just redo the problem and choose down the incline as being positive, and you would get then a plus 0.11. Minus sign is not a problem here, because I have fixed the friction to be in the right direction, correct direction. And since I chose up as positive, that minus sign just means it's going to go down. So everything is okay here, but it's not a bad idea to just, for practice, redo everything with the plus going down to convince yourself that there's nothing wrong with that.